All right, hello people watching this. We are doing whiteboards today, and I am going to record, so this is going to be a very long video, but feel free as we go through these problems to skip if you want to. So I'll give them a problem, give them time to work, then I'll write out the answer to the problem, and then we'll move on, okay? So if you want to skip through this and kind of go a little bit faster, that is totally fine. Number 3, this is where we're going to start. Find me the domain and range of this function.
I can't see
Go.
it.
You can't see it. Okay. Psych, that's not what I meant. Okay. There we go.
You are a liar.
Find me the domain and range of this function. Number 3.
What if I don't want it?
Sorry, you got to. Domain and range. List the domain and the range. And then give me a yes or no. Is it a function or is it not a function? Okay, just put it somewhere on your whiteboard. You don't have to regraph it. You don't have to do anything. This all looks good. I think we all look good. Brady, what are you doing, child? Oh, heavens.
Brady's a little
I can't see the board inside pointed toward me, but yeah, okay. We're looking all right. We're looking okay.
Am I right?
A little bit. Yeah. I think so.
Ow. And then if it's a function.
And then if it's yes or no, is it a function? Okay? That's okay. We're gonna go through one, and then maybe the next one you'll be able to figure out. That's fine. Okay. Domain is the x's. Okay. X's go left and right. So will he go to the left forever, to the right forever? Yes. So what do you put for domain?
All real numbers.
All real numbers. Okay. For range, will he go up forever?
No.
Yes. Will he go down forever?
No.
No. It's just y's that are.
Equal to 0.
But he's hitting it at 5.
That's the x.
That's the x coordinate. This is 5, 0. We want the y coordinate. So the lowest he goes is 0. Aha. Yes or no? Is he a function? Y. Vertical line test. Yes, he passes. Very nice. Okay, next. Do domain and range for this guy. Domain. Range. Yes, no.
What is there on here?
I don't know.
Is it what? Is it linear or a function? Is that what you're asking?
Do domain, range, and then yes, no. Is it a function? Any kind of function. Any kind of function. Any kind of
Wait,
function.
you show that to me.
Okay.
That's right. Am I wrong? Am I right or wrong?
It's not a racing game.
Hey,
Is past vertical
I
line?
got it.
That's right.
What are you doing, son?
A vertical long way.
One of them is wrong. Well, you got this one's correct. So domain is x and is the x's.
I'm gonna catch
X's go left and right. They go left and right forever. This should have been up here.
And you missed.
Right? He's going left and right forever. Okay. Now up and down. Will he go up forever?
Chill, stop throwing it.
No. Will he go down forever?
Ooh, what's that?
What does he touch?
Just sweetheart ball.
Sweetheart Chewy.
This is his range. He's only
I've been all over the floor and.
He's only gonna be one.
Hey, so wait a
Okay.
minute.
All right, so just really quick, domain, left and right, he will go forever, so he is
All real numbers.
all reals. The range
3.
is 3, so you can put like y equals 3. You can put like the set of 3. Some people put this 3. That's probably fine. I'll probably take it. Is he a function or not a function? Yes, he is. Okay. That's great. Let's me go to a next one. What else? Linearity, intercept, symmetry. All right. On to the next one. Page 19. All right. Number 3. Okay. We're going to do a couple things with number 3. First thing. Is it a linear function? Yes or no?
I can't even. Yes.
Is it
Yes.
a linear function? Yes or no? How do you know whether it's a linear function or not?
Because the x is, there's no exponent.
There's a y and there's an x. Okay, here's what I want you to solve for. I want you to put it in y equals mx plus b forms. So get it where the y is by itself. Do that real quick. Yep. Next thing we're going to do is graph it. So after you do that, go ahead and graph it.
Okay.
There you go. Now graph him. Graph him. Yep, after you get him moved, graph him. Okay, after you get him moved, graph him.
I want the ball, Dylan.
Looks good. I think that looks good.
I just look.
Woo! Nice.
Is this right?
Yes. Yours is going uphill. Very nice.
Is this right?
Yep. Good.
Hey, I corrected it.
I don't even have that much money.
I don't have that much on me.
You gotta put it off.
No, I was like, I don't know anything with that.
I want a ball.
What are you doing for it?
I want a them ball.
No, this is my ball.
Good job.
Okay, now if you connect the dots, is he going uphill or downhill?
Can you guys not think?
He should go downhill.
Dylan, can I have some of your
Maybe
ball?
not, right? So this dot is over here. Makes sense? So he'll.
Dylan, can I have some of your ball?
Always check that. Okay,
Some ball.
good.
What?
Okay,
Really? Why?
I wonder why.
Oh,
Sure.
seriously?
I don't like it.
From there, you go
So you
negative 2 and negative 2.
You go, you make it L, and then you make
Only on most of them.
C.
Only on that one.
Right?
Yeah, the very first one, and the middle one, and the last
But it
one.
looks better
No,
when
shut up.
All right. Here we go. What do you do first?
you
solve it.
subtract two.
Minus the 2x. Can you subtract 2x from 10 to make 8?
No.
No. I write the negative 2x first. Okay, then when you go to graph him, where do you start?
Start somewhere.
I'm going to talk about things that I saw multiple people doing. 10. 10. Woo. This is the y-intercept, so I want 10 up here, not the 10 over there. Okay, so I'm going to erase him.
When would kill me,
Okay,
right?
10 up there, and then here's another thing that I saw people doing that was not right. Negative 2 as a fraction is 2 over 1. So they went down 2 and over 1, and down 2 and over 1, and down 2 and over 1, and then they connected the dots, and he is going uphill, which means his slope is positive. But I want my slope to be negative, right? So I want down 2 over 1 this way. Ooh, this way, right? That's what he should look like. Got it? Perfect. All right.
I don't want to do
Is this linear or non-linear? Non-linear. What is he probably? A parabola. Y equals x squared, right? A parabola. Okay. All right. Let's go to something else. Let's go to estimating x and y intercepts like 15. Okay. Tell me on 15 where the x-intercepts are and the y-intercepts are.
The y-intercept is the origin.
And one of the x-intercepts is also the origin.
Zero.
Okay, so write them down. Write them down. Write down the x-intercept and the y-intercept. The x-intercepts, y-intercepts, that type of thing. There you go. Write those guys down.
2, 3.
X-intercept, y-intercept.
I'm done.
I'm done. Good for you.
You were so close, dude.
I was.
You are so close. It's not quite right.
How did I not get it right?
Oh, there's always
I got it. I got it.
I got it.
Yeah, yeah.
I got
I was
it.
on the right track.
Yeah.
I did it. There, I got it.
Technically.
Yeah.
I did it.
It should be 4-0, not 0-4.
Yeah.
What do we do the same
What do you
way?
mean technically? You said minus technically.
What?
You looked
No,
at mine.
yours is right. Everybody else's is technically right. Kind of. If I be picky, I like yours better.
I put well,
There.
Not everybody did that way.
There.
Okay.
I did.
All right. So here's the deal. X-intercepts. How many places is he across the x-axis? 2, right? Here and here. So my x-intercepts are at 0, 0, and at 4, 0. 0. Now, some of you guys just put 0 and 4. I'll probably take it, but these technically are the coordinates. That's fine. If you have a story problem, I think Macy asked me this yesterday. We did a story problem, and like it had like, what's the x-intercept, y-intercept? If it's a story problem, just give me the number that I want, like for the x-intercept, okay? So you don't necessarily have to put it as an ordered pair if that's the case, right? Like it was like 6 seconds and 0 was the height. You can just tell me 6 seconds. You don't have to say 0, 6 or whatever it was, right? What's the y-intercept? Same as one of the x-intercepts, right? So if you put 0, that's fine. The origin, yep. Now, a function can have how many x-intercepts total? As many as it wants to. How many y-intercepts? 1, because otherwise it's not a function, right? If he goes like this and has a bunch of places where he crosses, he won't be a function anymore, right? Okay, he won't pass the vertical line test. Okay, yeah, it was like this one. Like here, if I ask you for the x-intercept there, you don't necessarily have to say 7, 0. You can just say 7 and explain what it means. Okay. All right, let's go to. Should we talk about even, odd, neither? Do you remember what those were?
Nope.
Woo! Okay. All right, this guy. Let's talk about line symmetry or point symmetry.
That's line symmetry.
Okay, figure out which one he is, and then is he even, odd, or neither?
I can't even see.
Can you see this function? There he is. That one. That graph.
It is a glare.
Line symmetry, point symmetry, and then is he even, odd, or neither?
I don't know any.
Even
What
odd
was it,
or
man?
what?
The second one's not right.
It's even? I don't know.
What do you mean?
You have to re-explain. Oh,
Even
actually,
odd or neither?
oh, it's x squared. I got it.
Hey,
Yeah.
hey.
Yep, we're kind of remembering this, okay? All right, oh heavens. Do you guys want me to send this to you?
Yeah.
Too? Sure? Okay, all right. All right, does he have line or point symmetry? He has a line straight up and down, right? Like this, okay? He is even if he is symmetric with respect to the y-axis. So like the y-axis is this guy, he's folded in half. He has odd symmetry if he's symmetric with respect to the origin. So like here and here, that's origin symmetry or odd. He's neither if he's neither. Okay, now, here's my question. If he has line symmetry, is he always an even function?
No.
Give me a scenario of when he is not.
Absolute value.
That's still could be even. If it's not on the y-axis. Jacob just said it right here. Okay, let's say my parabola is over here. Is he have line symmetry? Yep, but his line that he's symmetric about is not the y-axis, so he's not an even function. He is just line symmetry, and he is neither.
Wait, the B even, doesn't it have to be?
It has to be the y-axis that he's flipped over, right? So this
Neither.
guy is neither even nor odd. Okay,
Is-
let's do.
Wait, so the B even, it has to be on the origin too?
No.
It has to go through the y-axis. Okay.
So the
So
last one was
It can go like
Even.
ink or like.
What?
so the last one was even, right?
Yeah.
Uh-huh.
Trevin.
Oh, I thought you said neither.
Trevin. It can go like ink or like ink or like.
okay, let's do. I don't know. Let's do just this one. This is x cubed. Is he have pointer line?
Point.
He has point symmetry, and is he even or odd, or neither?
Odd.
Odd, because he has a center at 0, 0, and he's flipped over. So like he goes like this, right? He's like rotated 180 degrees. Okay, now how can I change him so that he has point symmetry, but he's not odd?
You move him up.
You move him up. Sure, we can move him up here and make him like this.
Yeah.
So I can flip him over, and he does have point symmetry, but the point is not the origin, so he is neither. Does that make sense?
Yeah.
Okay, point symmetry, neither. Got it? All right, let's go to something else. Let's do, I don't know. Let's do one of these.
There, and I couldn't see.
Well, you don't need to see.
Yes, I do, because otherwise I'm gonna fail.
All right, let's do this one right here.
There you go.
This guy.
That's a rotor grid?
Can you find his x and y intercepts without graphing?
No.
No.
Yeah?
How?
Plug 0 in.
Yeah. If you're trying to find the x-intercept, you plug 0 in for
The other one.
the other one. I plug 0 in for y. Okay, so do that. Find the x-intercepts by plugging 0 in for y. Then find the y-intercept, plug 0 in for x. Do that real quick. Find the x and y intercepts. Find the x and y intercepts. You boys back there, you're quit wasting my markers.
Me?
Sorry.
What are
Trevin,
you talking about?
you're wasting my markers.
It's not a
Do
waste.
the math.
Or-
It is
X intercept,
Have a
y
calculator
intercept.
I can borrow?
no.
Hmm?
No calculator. I got it. I got it. I got it.
We're talking about Asians
Oh,
now.
lordy.
That's
Oh,
great,
man,
Jay.
this is a kind of an ugly function.
I do not care.
Very bad. Very, very, very
What
bad.
would be this?
I think this
Ah.
is right.
Yep. Did you get an answer?
No.
I think so.
No.
Plug 0 in for the other one and solve.
I think so.
Okay.
How would you do the X?
Alright, so for the x-intercept, here you go. If you're stuck, here it is. If you're plugging a number, plugging 0 in for the y, you're trying to solve for the x-intercept, plug 0 in for y. I want to get x by itself, so what do you move?
We got to move
5
it
over.
I'm going to add the 2 over. So 2 equals 5x, then divide by 5, so what's the x-intercept? 2 over 5, right? Comma 0 technically, right? Okay, the y-intercept, how do you find the y-intercept? Plug 0 in for
-2.
x. So if I plug 0 in for x, this goes away. 5 times 0 is 0. And it is going to be 0, comma, -2. That's what he is, right? Should we do another one of those?
Can we use a calculator on Thursday?
You can.
Okay.
You sure can. Okay, do this. Find me the x-intercept and the y-intercept with that one. Number 1. X-intercept, y-intercept.
0 equals. Oh.
Okay.
I beat you.
0.
X-intercept, y-intercept.
That's
Get your
easy.
x-intercept, get your y-intercepts.
It's
I like to move it, move it.
0. What are they?
X-intercept, y-intercept. I can't see your board.
0 and a 0.
Okay.
Now
Did I get it right?
Okay. If you're trying to find the x-intercept, you plug 0 in for y, 0 here. And I'm trying to solve for x. What's 0 divided by 3?
0.
0. So I have 0, comma 0, okay? The y-intercept, I'm plugging 0 in for x. So 0 goes in for x. What comes out for y? Let's see. If I plug 0 in here, 3 times 0 is 0. So 0, 0 is what he looks like.
How'd you do the Y one again?
You plug 0 in for x. To find the x-intercept, you plug 0 in for y. To find the y-intercept, you plug 0 in for x.
I got it.
How did I do the other one?
Okay, I get it.
And then you divide it by 3? Okay?
Like this.
All right.
Or get done before then.
Let's go to, let me see here. Let me see here. Okay, let's go to 27. Page 27. Okay.
Trevin, that's a big waste of her markers. Enough.
Don't watch this video because you're going to get dizzy.
I already am busy.
27. Here we go.
Actually, it's not just on me, but Jacob contributed.
All right, let's do this.
What? Oh, wait.
Number 7, this guy right here, I want you to tell me relative max, relative min, absolute max,
I drop out.
absolute min, okay? I bet you you'll get the hang of this. Absolute max, absolute min, and then end behavior. Do you remember how to start end behavior?
X.
As
approaches
x
infinity.
goes to infinity, the y is doing something. As x goes to negative infinity, the y is doing something. We're doing a bunch of stuff, okay? So tell me what the relative max, relative min, absolute max, absolute min, where those are, and then what the end behavior is. You might not have a relative max or min, or an
I'm
absolute
gonna
max or
end
min,
about.
okay? So fill in the coordinates for where approximately those guys are, okay? Where approximately. Are we gonna say that this one is higher than this one, or are they both on the same?
2.2.
What?
I already wrote it as an absolute
2.0.
max, so they're the same.
Okay, we're gonna assume that these two are level with each other. How about that? Okay, even though the one on the right looks a little bit higher, but we're gonna say that these are level.
That's
Okay.
stupid. Don't do
I'm
that.
sorry. That's what we're gonna assume. We're gonna make that assumption. Okay, we're gonna make that assumption and say
Not
that they're both
in
the same.
this house.
All right, you fixed it. Okay,
0, comma, and
you
2.
may not have a relative max min, whatever, right?
Two.
You might have some of them that are blank.
X equals
I'm done.
We'll check in here in a second. I don't wanna come by and check them all. This is a lot.
Y
Really,
goes
I gotta
Cool.
take out of mine.
Look at the three faces. Stop looking at that.
All right, did you get a chance to get them all done?
Hold on.
No.
Okay,
Okay.
I'm
no.
waiting.
Cookie dough.
I don't know, I can't see. We'll go through them. What?
I don't understand.
You don't understand? Okay, how many maxes and or mins do we have? What?
That's incorrect.
I'll say that again. How many maxes and or mins do we have? Three.
Can you tell?
Right? We have three of them. Okay, so let's go bit by bit. Let's talk about these. Assuming that these two are on a level playing field, let's talk about this guy. He is a maximum. Which kind? Is he relative or absolute?
Absolute.
He is going to be absolute. He is an absolute max at like -2 comma what?
Well, I made an oopsie.
2? -2 comma 2? Okay? He's an absolute max. What about this guy over here?
Relative min. Absolute max.
He is also an absolute max.
Well,
Okay? So absolute max at, let's say 2.5 comma 2. Let's say that. Okay? All right, this one down below here, what is that?
Relative minimum.
That's like 2.3.
It's a minimum. Is it a relative or absolute? Jacob says relative. Is he right?
Yep.
Why is it absolutely not the lowest point?
Because it goes down further.
It goes down further on either side. So this is a relative min, and that is at 0 comma -2.5. I don't know. So do we have a relative max? No. Do we have an absolute min? No. End behavior. Okay, as
Do you want to clean this?
what?
With your face?
Technically, we would have.
Yeah, if we assume that the right side is higher. All right. End behavior. As x goes toward infinity, you gotta listen.
Why go negative?
As x goes toward infinity, that means we are going to the right. As x goes toward infinity. On the right side, are we going up or are we going down?
Down.
Down. So we say negative infinity. Okay? As x goes toward negative infinity, that's on the left side. He is going
Positive.
on the left side.
No.
Oh,
Negative.
left side, he's going down as well. So that's also negative infinity. Right? Good? Good, good. All right, next. Let's do this one.
Are you really?
Okay? Relative max.
Say bye, Jacob.
I'm just gonna have you label them. So just tell me which one's which. So this is point number 1. This is point number 2. This is point number 3 and point number 4. Tell me what is what. And then do the end behavior.
Whoa.
Confusing much.
Is this all gonna be on
Yep.
the test?
Yep.
Well,
You're
I'm
not very
failing.
nice.
Whew, you're gonna be fine.
No, I'm
Okay,
not.
point number 1, point 2, point 3, point 4. What are each of those?
This
Relative max,
marker is
relative
dead.
min, absolute max, absolute min. What are
This
they?
marker's dead. This marker's dead. Can I pitch it?
Quit ruining my markers, kiddo.
I didn't.
Okay, throw it away.
Do you have to list the points?
No, no. I'm just trying to make it easier for you to, like, you know, whatever. No, you don't have to list the coordinate points. Is that what you're asking?
Oh, you don't? Markers.
No, because the coordinate points are kind of icky, so just leave them.
I'm done.
I don't know. Just put them down and check it. In a
Min
second
max,
when we go
min
through it.
max.
Okay?
Maximus.
Okay, yeah. Yep. Just wait and we'll check it. I can't read from that far. Well, some of it. I know your end behavior's right. Okay?
I'm not done.
Hurry up, Billy.
I did it. I did it.
You need a new marker?
I got one. one.
Remember, make sure you had two.
Alright, done?
Oh.
Did you get an answer? Here we go. We'll go through it. Alright, number 1, what is he? Min, but is he absolute or relative? He's a relative min.
Relative.
Okay. 2, is he a relative or absolute? Max. Relative or absolute?
That's what she said.
What do you think?
Relative.
Are you saying that they're directly across from each other?
Yeah.
Sure. So then he would be, I guess it doesn't matter. Neither of them are going to be absolutes, right? Because he goes forever on that side. So it doesn't matter. These are both going to be relative maxes.
Yup.
Yeah?
Yup.
Okay. This guy, number 3, he's a min, but is he relative or absolute?
He is min.
Relative. So we have no absolutes here on this graph at all.
Wow.
Nothing's absolute, okay? On the right side of the graph, he is going negative infinity. On the left side of the graph, he is going positive infinity. There we go. Good?
I think your pencil sharpener is broken.
What a bummer.
Did you try to plug it in?
No,
I don't know. All right, here's what I want you to do. Go, I'm just picking a blank spot. On your graph, sketch me this. Ready? I don't care what it looks like, but sketch me this. I want your graph to have
You're thinking of it.
2. Okay, let's do this. Can I give a hard one?
No.
Yes, I
Yes,
can.
hard
Do
one.
the easy one. One absolute
What abs, Max? That's me abs.
No.
No. You were.
No.
Okay, stop being a
Sketch
furry
me what he
now.
looks like.
No.
He looks like that.
One absolute max.
Wait.
Okay? I want to function
No,
that as
yeah.
1 absolute, 1 relative max,
Fix it.
a relative min, and infinities, negative infinities on both. What?
He looks like
You
a
messed
penny.
up the negative infinity.
Uh-huh.
on
You
X.
need no,
Second X.
you need X to be
Oh,
negative.
I'm sorry.
infinity.
Yeah.
You're right. There you go. Okay. All right, sketch me what it looks like.
Genius. I'm done.
Okay?
Get a drink of
I'm not
water.
gonna put
Yeah. There you go.
Bree, drink your
That was
protein shake.
convenient.
Can I get a drink
Do
of
we have an
water?
absolute min too?
No absolute min.
Brady, just drink your protein shake.
No, it's nasty.
to do.
What
That's
does
why
he
you
look
chug it.
like?
No, I
Sketch
couldn't.
what he
I was gonna
would,
throw up if I
could,
drink anymore.
could possibly look like.
Just chug it all in
Hence
one
why you
go.
only need
No.
Take it.
Sketch what he could possibly look like.
10 minutes, 10 minutes.
Oh, it
Not
doesn't,
much.
can't have an absolute min?
No, we didn't have an absolute min.
Jace, you.
That's not an absolute min.
No.
Yeah, you're all right. What? Is that absolutely the lowest point on the graph?
No.
Yes.
No,
So
it's
can
not.
you keep going down?
Because I'll keep going down forever.
Duh.
You know? Seriously?
How come?
All right.
There.
I don't know about you. I don't know what piece of information you start with. You gotta listen. Listen. I don't know what piece of information you start with, but I start with this part. On the right, he's going down. On the left, he's going down. Okay? So, I don't know what your graph looks like. I just know he's coming like he's doing this on both sides, right? Okay? I have to have 1 absolute, so 1 high place, and then 1 that's lower. So something of that nature. That would fulfill all of those. Jace,
Yes.
this guy is not a absolute min.
I know that,
Okay.
but I thought the arrows were an absolute min.
He thought
No.
it was going down.
No. Arrow is not a stopping point.
Well,
You
I'm
can
feeling-
only label the stopping points. All right. Okay, so we can do that part. All right. Let's go to next. I'm going to make you dizzy on the video, whoever's watching this. All right. Number 3, sketch that one. Those requirements. Sketch that one.
Okay.
Okay? This one should be real quick.
There you
I
go.
do not do that.
Yeah.
Try.
Go now.
No,
Okay,
the
give me
balls come out.
Try this one. You can do this. Hey, put that away.
How do I
This should be
start it?
easy.
Nope. Do this.
Linear's just a straight line.
Literally,
Yeah.
like, you don't remember
Hey.
that you-
Sketch a graph of this function. Sketch a graph of what he looks like.
Watch your mouth, little boy.
Okay, here you go.
Sketch a graph of what he looks like.
Okay, Jacob.
Has a lot of information up there, and most of which you don't need after like the first three
Check,
things.
let me check yours.
Okay, can I compare?
X-intercept.
I don't know if I did it right.
5.
I need the
really don't think I did.
Is there ultimate
I got this.
Dylan, you cheated.
Okay.
Oh, this is easy.
After the first three pieces of information, you can pretty well ignore the rest of it. Okay. The x-intercept is 5 over here. The y-intercept is 5. If I know he's a linear function, he looks like this, so I don't even have to read any of this stuff. But it will still apply. This is what my graph looks like. Got it?
This is easy.
Yeah, that one's not too bad. Let's give us a bunch of those on the test, right?
Yeah, give us all those.
Okay.
Okay, I don't want that. I want,
No.
yeah, let's do this one. This one's a little bit harder. Number 5.
Oh.
Oh man.
Can you do all of that stuff? Number 5. Do that.
I just made the ultimate game.
Non-linear.
Okay, I need to erase some
I'm
stuff.
confused now.
Now we're confused. Oh boy. Number 5. Try to incorporate all of those things.
I'm trying to incorporate what this is.
Go. Just start at the top.
I'm gonna.
Put
Does it
things
look
on
like
there.
that?
Think so? I don't like that you don't have an x and a y axis. That drives me nuts.
What do you mean he does have an X and Y axis?
What?
The
Oh,
y
no,
intercept is 0
I
and
did
1.
it wrong.
Move your line. Oh no, you were fine. Just move your line.
I got it.
I
Are you
didn't like it.
pointing down? I don't know.
You like
Oh, I didn't like it.
Okay, that looks kind of maybe good. That looks kind of maybe good.
I do it right?
That looks kind of maybe good. Okay.
I got it.
Yep. Non-linear. So he might be a parabola. He might not be, but he might be a parabola. Okay.
It's a parabola to me.
You think so?
Yeah.
All right. I'm gonna maybe draw him not as well. No, that's not
I
gonna work.
don't think I got
He has to be a parabola. The x-intercept -1, y-intercept +1, excuse me, 1 0 and 0 1. He looks like this. And non-linear, continuous, symmetric. He does have symmetry. X = 0. Okay. So let's do this. Let's say that we have this going on, and I'm going to do this. Can my function actually do that?
Yeah.
He's symmetric, okay? But is he increasing for all values that are on the left side of 0? No, because he goes downhill right here. So what's that mean? It's a complete parabola. He has to be a complete parabola. So I've got to get rid of him. What?
I wish I was smart.
There you go. He's a complete parabola. All right? Good? Okay, we can do those. All right, let's find something else here. What else do you guys want? Graphing linear. Oh, should we do some more graphing inequality stuff?
No.
Nope.
Like what we did the last time?
I just
No?
want to be done.
We got 5 more minutes left.
I know, I just want to take care of.
Let's do. All right, here's what I want you to do. Number 7. Graph him. Number 7. Graph that guy. We'll do a couple more and then we'll be done.
How about just one more?
What?
One more.
Okay, do this one and then one more, and we'll be done. Okay? Do that one and one more.
Oh my
How'd you graph this one?
god.
Graph that one. Graph it.
Hard.
Graph it. That's not that hard. You could graph him by finding the intercepts.
I never didn't then know how to do that.
You plug 0 in for the opposite one.
Oh, okay.
Like that.
Oh.
Jets rebrand.
Do you want us
Did I
to
get it
solve the
right?
equation?
Tell them the Jets are rebrand.
Hold it up again. I think so, but I can't really see it.
Yeah.
You did up 3 over 1 instead of up 1 over 3.
Right here. Jets are rebrand.
I'm not actually, but I should.
Yeah, it should be up 1 over 3.
You know what else is gonna happen?
Right?
It's the Cowboys here.
You did up 3 over 1.
There you go.
Always the Cowboys here.
It is always NG.
Man, oh man.
Done, man.
Man, oh man.
I'm done.
So the y
Alright.
intercept is 2.
But the x-intercept.
X-intercept is
Who's gonna win?
Eagles.
negative
Negative 6, yeah.
Yeah. Okay. All right, this one. Do you solve for y? Is that how you graph it?
You can.
Sure. Let's solve for y. All right, let's kick the x to the other side. Add x, add x. 3y equals x plus 6. All right, what is this? What does x over 3 mean?
It's divided by 3.
1/3 x is x over 3. 2. Okay. So we start at 2. Start at 2, and 1/3 is the slope. So you go up 1 over 3, or on up 1 over 3, and he goes this way. Oof. If you connect the dots. All right, last one. Let's do
29.
29. Oh, sure. Let's do 29. He's already solved for you. Do 29, then we'll be done. Boys, do 29 and then you're done.
I thought it looked easy, so
You think it is easy?
Good job.
no.
X is greater than -5.
I think
Graph him.
it looks easy for people that are smart.
X
Which
is
is-
greater than -5. Graph him.
Oh yeah, greater than -5.
Oh man, did I do this wrong?
Like that.
Wait, hold your board right toward me. Jacob's got something not quite right. Trevin's got something not quite right.
Flip it 90
Ha,
degrees.
Jacob's
No.
right.
Brady, flip it 90 degrees. Other way. Other
Other
way.
way.
Other way.
Hey,
That's maybe the way. Yours is not quite right.
Stop, Billy.
Yours, I can't even tell what you're
There
trying to
you
do.
go.
Here you go, teacher.
Teacher, look. Look, teacher.
And guess
Teacher,
who?
look.
And guess who knows their right?
Teacher, you're gonna miss it. Look, teacher.
Right? No.
This way.
Tic
If
tac
this
toe.
is
Give
right.
me
No
next,
way.
Give me no. Give me
There.
30 and
Not right. There you go. Technically, yeah.
How about this? I mean, this is the wrong side. This.
All right.
Oh.
-5 on the x-axis. Here you go. Here's your answer. Dylan, watch this. -5.
You go first.
And he's going to be a line straight up and down, except he is
Horizontal.
Greater than, not equal
Oh. dotted, right? Then we shade to the, which way?
to. Left.
To the right, greater than, to the right. There he is. Okay, dotted line, that's the key. If you're gonna graph him like that on a number line, okay, so this is how Zach did his. He just went ahead and did -5 here and did that. That's technically right as well.
Hey.
Yep, very good. All right,
Technicality's all that matters.
goodbye people watching this video.